Hey, good day, and I want to welcome all of you to another session of CompTIA A Plus. So we are still looking at Core 1, still on Core 1. So I want to encourage you to go over all our videos on this CompTIA A Plus training. So so far we've done lesson 1, lesson 2, lesson 3. Now we're now on lesson 4. So I really want to encourage you all to go over our lessons so that it can be updated and be up to speed to what we are doing. So this is CompTIA A Plus. So here we take you through the foundation of IT security, computer engineering, and even if you want to go into AI, programming, so this is the foundation for you if you are starting your course in IT. Okay, so we're going further. Now we're going to move further to local networking hardware. So how do we compare networking hardware? So we're looking at comparing local networking hardware. So in our previous classes, we've talked about the hardware itself, how to build the hardware, how to set it up. Then of course we talk about the BIOS system. We also move further, we look at how to troubleshoot the hardware. So those are just the computer hardware. So now we're going to look at networking hardware now. Okay, so again, my name is Samuel Bemi. I'm very much experienced, so I have over 23 years experience in the IT industry. I've been in the industry for a very long time. So I felt it's time to give back to the society, to give back to people, to support people with my wealth of experience, because I've been there from a very long time, As IT evolving, I'm evolving along with IT. So there's a whole lot you're going to learn from me because I'm very much experienced. I also want to encourage you to subscribe to my channel. So if you've not subscribed, please subscribe to my channel so that you can be getting my videos, because I'm doing this for you. I could have said to keep my knowledge, but I want to share my knowledge out. So subscribe. When you subscribe, you'll be getting our videos, updated videos. Because every time I post videos, latest videos, and the more we post more videos, the more we push in more content. So after this duration of this program, this A Plus program, after A Plus, we're going to move further, to networking. We look at networking. Then of course we're going to look at what cyber security. So you're in for a very big one. So just stay with us, stay tuned to our channel, follow our channel, subscribe with us, and like and make comments. If you have any question, you can go to the comment section, ask a question, I'm going to answer you. Okay, so that is that. So just hit the like button, and as well subscribe. So compare local networking hardware. So let's start right away. Okay, so here we are now. So our topic for this lesson, we're going to look at number 1, how we compare network types, compare network types, then compare networking hardware, explain network cables, compare wireless networking types. Okay, here we are. Here we go now. So LANs and WAN. So when we talk about local area network, we have to understand that local area network fall into a category. The category of a standard called Ethernet IEEE 802.3. So that's the local area network falls into, and that includes our normal network we have in our office environment, our home. Those network we do, office workspaces. We call them LAN, local network area. Now, the one that most of us are we are conversant with that we're used to is the wireless network, because most of us, we have our mobile phone, wherever we're in the airports, we want to check our email, we just put our mobile phone, our data is on, we could just connect to the Wi-Fi in the airports, even the office, you could go to the office and go to the bank and you might decide to use the Wi-Fi there. So the wireless network, which is WLAN, it's called wireless local area network. So it's similar with with local area network, but this time around, it's going to be without wired, so it's called wireless. So it comes with a standard called IEEE 802.11. So your Wi-Fi network falls under this category 802.11. That's the wireless network falls in. That's from this category, then they begin to build more standard. Then of course we have the WAN, so which called the wide area network. So this is the network that we use today. So it's a grouping of networks upon networks from regions to regions all over the world. So that's where the internet falls in. Then we also have the metropolitan area network too. So metropolitan area network is a combination of LANs within a city. Within a city, it has a geographical range, so not so far away, up to like 50 kilometers and above, but not so very far. So you could look at a network within the city or within an area. We call it a metropolitan area network, whereby you can have networks, buildings combined together. We call that a metropolitan. Look at the word metropolitan, within a city, within an area. Metropolitan network. Okay. So now we're talking about LAN area. So take a look at what we have here. So this is a typical example of a LAN, right? So we have a SOHO and enterprise network. So a SOHO is called small office, home office. That is SOHO. So it's usually this kind of network you have in your home. You have a router like that, see, like a router. So a router that can just supply, we call it wireless router. It gives you, provide internet connection. I also give you some ports where you can connect to your local computers. You can also have, a network switch. We're going to explain network switch very soon. Network switch there, then you can have your wireless devices like your laptop, your iPhones, and the rest. Then of course, on the wireless router, there's a port on the router, a connection on the router that you can bring to the internet. Where your internet comes from, which is the ISP. So on that port here, that's what you see here. This is the local LAN. This is for your LAN. This is the internet. So here now, you see there's a cable like this that goes on the wall. So then from this cable that goes on the wall, it goes to your subscriber who are subscribing for, which is we call it the modem. We're going to explain those very soon, modem. So the modem now goes to the ISP. So this is your ISP now. It provides the internet for you. So your ISP has its own cable that comes to this router, which supplies the internet to your private network that you have here. Okay. So now we want to talk about enterprise network. So we've moved away from we're looking at enterprise network. So enterprise network is a network that has to do with scalability and reliability. When I mean scalability, means that the network is scalable. So you can start with 20 users today, and within a year you might have more employees, more staff can come in. Then you buy more system and add to the network. So what you've done, you scale up. So you could have, and it's reliable, unlike wireless network. In wireless networking, there are a lot of things that could affect you. And also in your small office network, it's just 4 users. It's not that scalable, you understand, because it's just few users are there. And it might not be reliable because you just have one wireless device, one router there. If the router goes down, then everything is go down. But in a enterprise network, there are many switches. If you have more than one router that are being used in a wireless network, like what you see here now, see, this is the typical enterprise network. In this network here, you have these are switches, we call them work group switches. So in the event if the switch goes down here, if one of the switches goes down now, right, you could draw a cable from this place and attach to this switch, for reliability. You understand? So why you wait to get the other switch, this other switch, you understand? So in this kind of network, in an enterprise network, The network it provides reliability and scalability. So you take a look at this place now. This is one office, right? This is one office. This is a switch. This is a wall socket where all the network cables are attached to the computers. These are the computers. Then here now you see in this place now we're having a switch. So we're going to talk about this ones later too. I have a switch here that connects to your devices to and printer. This is another section of your network. Then here we have another section of your network. It's all about what the Wi-Fi, wireless users. So they work on this now. So this people called distribution layer, called distribution. This place here we call it core. Now is the area that connects you to what your routers. So we call them DMS zone. So we call it demilitarized zone. So that is the kind of private network that is not part of your entire network, but is part of your organization, but not part of the entire network. So in most cases, those kind of network, they can provide remote access and also bring the internet. So your internet provider connect to that zone too. So these are where routers come in. We're going to explain these ones later. Okay, so let's continue. Then we will look at data centers and storage area network. So when we talk about data centers, we're talking about what? Dedicated servers. Those are data centers. So you have so many servers in a dedicated area. We call them what? Data centers. So you could have a city or a place where all your servers are stored. They have good networking, power, climate, physical access, restriction of physical access control. Access control is put in place. Your power, climate control, everything is just in an isolated place. So we call that place a data center. So everything is within a city, within a place, a dedicated place with servers, rack of servers. They will call it a data center with storage facilities out there. So what they do is to provide storage service to your clients, and other users within remote locations as well. So we call it data centers. Now, the next one we have is called storage area network. A storage area network is a network, that has a pool of storage devices. So it's different from data center. So you could just think about a storage device. You could think about a storage device like a hardware that is connected to a physical computer. So you have your hard drive that is connected to your physical computer. What that hard drive does is provide storage. Now, in networking, you could say, okay, I want to have a storage on the network. So instead of having my information stored on the physical computer, in other words, if you're not having your storage on the physical computer, you want to have the storage on the network so that everybody can save to the network. So we have called pool of storage devices. So what happens now on the network, you can have a device with pool of storage devices. So that device is stored, is connected to your physical network. Your physical network is connected to that device. So on that device, it's just storage, pool of storage hardware. So you could have up to 8 or 10 storage devices inside that place, inside that devices. So that device is connected to the network. We call that what storage area network. So all clients' application, they connect to that storage. You get information. So when clients are working, servers, all of them are working, they are connected to the storage device. So the storage area acts as if it's stored physically on your physical machine you're using. So you could see a drive, just like you have your C drive, your hard drive. You will see the drives are there as if they are part of your physical computer, but they are not physical. They are on the remote storage. So we call that a storage area network. So they have fiber channel. Fiber channel is just a connection on the storage device that you enable the storage network to be connected to the storage device, to be connected to the network. So call it fiber channel. That's what they do. Then of course, internet. The internet is one that gives you access to the internet, like ISPs. So it carries that internet connection. That is fiber channel. So it carries the internet connection. So all your storage devices, they have fiber channel that provides access to your network, so that you can be able to connect these devices to the network, called a fiber channel. Okay. Okay, so next in line is wireless and cellular connection over few meters. So this one is almost self-explanatory. So it's all about you having your devices, so you have your smartphone, and you could make your smartphone be parts of your network. Very easy. So how do you do that? Just go to your hotspot, go to your wireless network on it, and you will be able to connect to the system too. After you can also make your phone. You can make your phone a network. You can make it a network like to provide internet. How do? You're going to share the hotspot. So you have your phone. You can go to settings on your phone, and you could look at hotspots. You could look at settings, and you can look at hotspots. You enable hotspot. Your hotspot is enabled. Put the password. Then what happened? Then you can, if for some of us that don't know hotspot, you could Google it. Right, you Google it, but it's just simple. You just go to settings, go to network, then you see your hotspot there. So you should use hotspots that are providing wireless services. So enable your hotspot. That means if you're unable to buy a sole router in your house, right? If you don't have a network in your house, since you have mobile devices and your mobile device has a network, has data inside, what you have to do is just share it, just on your hotspot. On your hotspot, as soon as you on it, you share it. So as soon as it's on, then you could go to your computers and let them see the hotspot. Then you access the hotspot, just put the password, access it. Then they need to use the internet. So your hotspot has given, your phone has provided internet support to every other users. So that is about the hotspot. You could Google it, hotspot. Now, Internet of Things and wearable technology. So when you hear about, each time you hear about Internet of Things, it just means that all devices that now have access to the internet. That's what it means. All devices with access to the internet, because the Internet of Things. You could have a washing machine. They have fridges, your motor cars, all those technology now. They're now using. They now have access to the internet. It's called Internet of Things. Now, wearable devices are smartwatches. You wear smartwatches and everything else you could wear that have access to the internet. We call them all Internet of Things. So they're all part of network too. Okay, so we move now to topic 4B. So now we're going to compare networking hardware. Okay, good. So the first on the line is what we call the network card. So what is the network card? Now, first of all, you have to understand that the network card is the most important in networking. The most important thing. Because without a network card, there will not be what? Network. Your devices, your hardware, your computers cannot be part of the network. So we talked about earlier LAN 1. So how do you have access to the internet? Which means your device, you must have what? A network card inside, so that you can have it. So the network card is a physical interface that you can install in your computer system. So when you install it, they carry electrical signal. So they are transceiver, which means they can receive signal and they can also send signal. So later on, I'm going to explain some interesting things to you about networking and network card, how they perform and like that. But just now, the network card is a physical device, a physical interface that you connect to a device that provide access card. Now, if you are wondering, what a network card is, I'll just take you all the way to Google. So let's just go to Google and see what a network card is. Physical interface of the network card. Let's go to Google. So here we are. You can see Google. Then we'll just see network card, right? So here we are, network card. So let's see. This is the network card now. Just take a look at what it is physically. Okay, so these are a network card. See. So when we were in lesson 1, we explain cards for you. How you can install a card on your computer. We explain all these ones for you. So this is a network card you can insert on the computer. So insert it, it provides a physical interface. See, these are ports. So this one it provides a provision where you can connect your network cable. So the cable goes to these ports that supply with your internet connection and also make it part of the network. So this is a typical example of a network card, right? So you can read more about it, explore more about network card. Okay, so that's network card, right? So very important. So the network card has its own address too. They call them media access control. We call it the MAC address. So the MAC address is in X format. So when we say X format, we're talking about both numbers and alphabets combined together. So we call them X format. So that's the address. So the address is, typical. You will see a diagram like this now. This is a typical example of a MAC address, right? So we see a typical address with a MAC address. I just want to show you a very clear one. I'm seeing one here, but this seeing here one day, I just like, but this is all about here. Excellent. So this is a typical example of a MAC address. Typical example of a MAC address. So they are just like this in X format, right? So hexadecimal format. So that's how they have method card. The address is like that. So typically in X format. So you see all this address. If I see more, I'm going to show you MAC addresses, right? So they are in that way. So every network card you have, as soon as you get a computer, you can check the MAC addresses. So they have MAC address. Later on, I'm going to explain to you on a separate video when I'm going to talk about some technical things about networking, how computer work, how they operate the network. I'm going to explain network card in details, how the network card work, what it does. I'm going to explain in details. All right. So let's make progress now. So we're going to move to the next slide. Okay, so the next thing we're going to talk about is called patch panel, a patch panel. So some of they are not aware of all these kind of connections that goes on in a company. So when you go to companies and you go to your office, wherever you go to the cafe, you go to the airport, and you just start working. But there are some certain things that makes you to have access to the internet. There are some certain things that enables you to be able to have those assets you're having, right? So all those things you see that enables you to be part of the networks, we call the patch panel. See, these are called patch panels. So patch panel is just for what it does, just help to identify network cables, just for cable management, because all the cables that comes to the network, so they go to what call, for instance, now your computer. For your computer to be part of a network, there must be a cable that goes in. So what the cable does is carry electrical signal, right? So you join this computer to the other. So that cable that goes to your computer system, it has to connect the other terminal. The other end have to go to the distributor, which is the switch, right? But in most cases, for identification of those cables, for identification of the cables, so they have to have what called a patch panel, and the patch panel has numbers on them. Like I see numbers, see they have numbers. For instance, now, you are the network administrator of a company, and you are the one in charge of the network. You must be able to simplify your network in a way that it's easy for you to identify them, who a user is, which computer is the network, which ports are they. Because like you see, these cables, all these network cards, see these patch panels, they have numbers, and these are ports, see? All these are ports where cables are connected. So if you just don't simplify it in a way that you can equally identify which computer is connected to which port, it's going to be hard for you when there's a problem, because you just be unplugging cable, you don't know the right one to go to. So if, for instance, now your computer is in finance department, you could just this computer in finance, you can label it finance one, that you can link it towards a switch port called 1. So you know that your finance 1 is on port 1 on the panel. So similarly to this panel is just for cable management, right? Then you cannot connect that one. Take a look now. See, these are the patch panel. Is this the back? You see? So you put the patch panel at the back of this is the cable I was telling you. So the cable from the computer comes to this place, and let's assume this is port 1. Then the front part of it is what you see now, the numbers. This is the back of the patch panel. The front of it is what you see here now. All right? So you don't need to bother about how to set it up, how to install these ones. So there are network installer that will come and set all these on for you. You don't just manage them. That's what you have to do. So you don't need to bother, how do I set all these on? No. There's network installer can install these things and arrange the cable for you. Or you only just to manage them. So what you have to do, you just know that this one is account system port 1. Then on your patch panel, you link the front side, which is the front side. You take a cable, you patch a fly cable, neatly configured. You put it on port 1 on that patch panel, then move to your switch and back to port 1. So you already know easy identification. So you know this computer is connected to port 1. of that switch. So similar that what you do for all your system, right? So this is the back and this is the front. So this is the back side and this is the front side. Okay. So the next thing you want to talk about now is what called hubs. So hubs are actually that provision whereby all devices connect to. That is hub. So hub are that device. So they give you all your network, all your computers, they connect to the hub. See, this is computer, this is computer. All of them they go to the hub. So the hub is one that provide that connection for every computer. It's like a central controller where everybody connects. For you to be computer to be part of the network, you must have a hub. So that's the hub. But the hub is actually obsolete these days. It's not more in use now because the hub is not that intelligent device. So beside that, it doesn't carry full signal. So call it half duplex network. See, the hub is called half duplex network. Why would they say half duplex? Now half duplex because what the hub can do, right, is to receive signal, right, and not interpret the signal. So receive signal does not interpret it. And beside that, so it's a one-way. Half duplex is a one-way in the sense that it can only receive at the time, but it cannot send. So the hub can receive a signal and it cannot send, or it can send but cannot receive. Now, if the hub is sending signal, if other transmitter are coming in, the hub cannot receive them until it finishes sending that signal before it can attend to the other ones. So that makes, because of this functionality of the hub, that makes the hub at times to be slow, or collision domain. Because since the hub is half duplex, when a transformer is coming in, right, and the hub is busy trying to process one information, because it's half duplex. So everyone that is coming in, like I said, half duplex, they can only do once. They can only either they transmit or they send. So if they are transmitting, they cannot receive, or if they are receiving, they cannot transmit. So if the hub is transmitting and somebody is coming to receive, the hub will not be able to receive it. So all these transmitters that come in, they have to wait until the hub is finished processing what it's processing. They have to, everything comes, they have to wait. So when they are waiting like that, what happens? They queue collision. Now they will not create a collision in the network domain. So collision domain, that will not affect network performance. That means nobody can transmit. So that is the problem about the hub. Nobody can, because they create collision domain. Nobody can transmit. So everybody just jam each other, just like a traffic. They create network traffic, network jam. So which is not called network bottleneck. Everybody will just stay. All devices will just be jam packed. There will be traffic. So in most cases, to clear a hub network is to go off the switch. When off the switch, every packet will now be dropped. Then when you on it, users will have to transmit it again. And the same thing, if the same thing occur, if the same thing happen again, and it will affect performance. Because the hub by default is a half duplex network and create collision domain. See? So that is hub. So we're going to talk about topology. So in a separate topic, I will explain topology. So I'm going to take another class we'll call the class networking essentials. So I'll take another class called network essentials so that I can explain most of some of these things to you: network cards, switches, hub, star topology, what topology is, IP addresses. I'm going to take all those things for you. All those things, I'm going to take them separate classes called networking essentials. So that's why I said always subscribe to us so you can get full lowdown of what we're going to do. So I'm going to send that into I've been in this field for 20-something years now, so you are with the right person, So I'm going to mentor you and see that you become very sound in technology as you move to your whatever area you're looking at, going to cybersecurity, whatever. You're going to ensure that you're going to have very solid foundation and good background. Right? Okay, so let's continue. So that's about the hub, right? Again, I told you the hub is now obsolete, so nobody get the hub anymore. What we get is called switches. So that is switches. So switch is the one that now provide full duplex network. Full duplex, because the hub is half duplex, full switch is what? You see? Switch is a full duplex network. See? Why full duplex? Full duplex because it can receive signal and at the same time send the signal. Unlike the hub that can just do one. So the switch can do both at the same time. By doing that, it has always break collision domain. So there's no collision in the switch network. The switch is very sensitive, very sensitive. And again, it's just like the hub, like it's in a topology called star topology. I'm going to explain this one in a separate video, topology, in a separate video in Network Essential. So just ensure you subscribe to us so you can. When I'm done with the whole of this A+ training, then I'm going to create a separate video where we explain Network Essentials. All right, so just follow us. So after the whole of A+ training, which I believe, in a couple of lessons, I'm going to finish the A+ core 1 and core 2. Then I can start explaining Network Essentials in separate videos. It's going to be a separate topic, a separate training. All right, so we'll talk about star topology and so many things I won't talk about. Okay, that's fine. So let's see switch. So this is switch now, right? So a switch is very intelligent. So we call switch intelligent devices. So they avoid collision in network. They avoid it. Right? Switch is the reason why most of the times you have a fluent network, a free network. When you go to company at times, see they're accessing internet, they're working swiftly and efficiently because of switch. So this is a switch now. Now every port of a switch is on its own. Know that every port is on its own. So that's how I've heard the switch are intelligent devices. Every port of the switch is on its own. You understand? Now, why do you say that? Because what they create their own collision domain, unlike the hub that everybody be in one place. So that means if a switch now sent in, if a device on the network sent a transmission to the network, what happened? The switch will first of all want to know about that network, about that device that sent that transmission, right? So how would the switch be able to know? The switch has a place we call the MAC address table. You see, this something like this. We call it the MAC address table. So remember I told you earlier, the MAC addresses are what every devices of a network. They have a MAC address, they have address that uniquely identify them for other devices. So since a switch now is all about what ports, so the switch can have several ports, 24 ports, 18 ports, which means 18 ports means you can take 18 computers. 24 ports, you can take 24 computers. So every port of a switch, right, has a MAC address. Just like your devices too, your PC. Your PC has MAC address. See, all these computers, they have a MAC address. All of them, they have a MAC address, right? So all computers have a MAC address because why? They have a network card. Remember, they have a network card that is installed on them. So they have a MAC address. Okay, so take a look now. Now let's see what happened in this place now. Look at this one. See this host AA, right? So host AA now, see host AA sent a frame to BC. So host AA trying to send what? A communication. Frame is the right word there because what? In switch network, what they talk about is about frame. Because they deal with MAC addresses called frame. It's technically, so if you hear the word frame, they're referring to a switch. Again, I will teach you some things. I'm going to tell you something about something very important in networking. We call the OSI layer. I won't tell you later on. Very important in networking, so I can know some certain things, right? Okay, so host AA now. Host AA, right? This is host AA. So in host AA, you can find out that host A want to compute with host B. This is host B now. So as soon as host A sends a transmission to the network, right, to compute on B, the first thing the switch should do, look at what we look into is what is MAC address table to know if it has what a information about what host BC, rather not B, host BC. So you should look at his MAC address table where all devices are stored. So since the switch is the first time the host A trying to communicate with host BC, the switch does not have information about what? About host BC. Right? So what the switch should do, remember we said the switch works, every port is on its own. So usually it was the hub. This hub would have sent out information to everybody on the network. See? And when it sent out to everybody in the network, what happened? It will not create a collision on the network. Everybody will not see the information. And when they see it, everyone will attend to it. Right? So as long as you try to attend to it, which means they're going to be what? A collision, because people are trying to access that information to know if the information is from them. So in switch network, it's not like that. So the switch receives it, this information from what? Host A receives it now on this port. I told you every port in the switch is on its own. So this is the port called GO of this switch. See? GO. That is the port for the switch. So the switch port is called GO. As it receives it, right, it will look into the MAC address if it have the MAC address for its destination. So it doesn't have it at that time. What does it do? It will send the broadcast information. When you send the broadcast information, not broadcast, to send the unicast information. Just why? He knows the information is coming from what? Host A. Right? So information coming from host A. Host A already includes the destination address, which is BC address. So since the switch sees that, okay, this information for host BC, you just send a unicast straight up to what? Host BC. Without disturbing other people. Nobody sees it. I mean, all these ones, they don't get, no, see, G1, G2, G3, G4, G6, and G5, they don't get except what? Host BC. Right? As how BC get it, so you see, host BC MAC address now is now stored on what? On the MAC address table. I'm just, there's something called, in network, there's what called three-way handshake. Right? Because what you see now, why this MAC address table is complete, because at the time, this means that the switch have already learned about every devices on the network. The switch have learned about it. So you know what the switch knows about, has about information about G1 MAC address, that's G2, all the MAC addresses. But before the switch has this one, all the MAC addresses here, there are processes that must have happened that is not explained here. That's why you should look out for my words. Network and essential class. I'm going to explain what happened. How the switch knows about, how they know about all these addresses you see, how they come to know about them. I will explain it in our network essential class. So follow us and subscribe to our channels, and you're going to get all this information will come to you. So ensure that you follow our video. I'm going to explain all those things. So like I said, I mean, I've been in the field for a long time, CCN certification, MCSC, I've been there for a long time, working as head of IT, leading IT teams, working as network engineer. You know, today I'm into system engineer, system administrator, network administrator. You know, today now, where am I? I'm a cybersecurity expert, you know. I'm cybersecurity professional. That's where I am right now. So it's my choice to mentor you people, to see that, you know, I lead you guys and give my own experience. I want to pass my knowledge, what I've gotten with all these years, I want to pass it to you. So it's going to be a waste of time if I spend my time doing all these things and you don't subscribe, don't follow my videos, right? Because I'm spending time doing all this and I'm doing. So it's very important. Okay. So in a nutshell, what we are saying here is that you should just make a point-to-point connection. You check the MAC address table. It sees where the information is coming from. You just send it straight. That will happen here. So host A is going to host BC. The C sees that, it sees the MAC address. This is what host AA. So the MAC address AA is to what BC. This is BC, right? This is BC. So this is BC. See BC. It has it and sent to G5 BC. So that will have here G5. So okay. So we have some few things that I want to talk about here. So we have a call. Okay. So we have a call managed and unmanaged switches. So I explained switches now, right? So let's see. We have 2 types of switches. So we have managed switches and unmanaged switches. So when I say unmanaged switches are just switches that they're just like hub. So if you look at some companies there, they have some switches where they just connect network cables, especially small networks, small home network, a private home, small company. They just get this. They are cheaper. Get all the cheaper switches. You just connect network cable, connect to their computer, and they start doing network. They're working. So those kind of switches are called unmanaged switches. In other words, you don't need to do any configuration on them. They're plug and play. As soon as you buy the switches, say this is just buy the switches. It has ports like this. These are ports numbers, right? It has ports. So on the port, you just plug a network cable to it and plug to your computer. Put IP addresses. The moment you do that, the computer will start working. So those kind of switches without configuration, we call them what? Unmanaged switches. You don't manage them, just leave them like that. But a managed switch, right, is the one that even if you plug a cable, you can have to go there and go and configure the interfaces. So you have to go and put IP address on all the switches, configure them. You can create VLAN. You know, it has a web or command line where you can write commands. So a typical example are Cisco switches, VLANs. If you hear about VLANs, we're going to talk about VLAN. If you hear about VLAN means virtual LAN. So those are typical examples, virtual LAN. So VLANs are private way of working in a network environment. Don't worry, we're going to see VLAN later, right? I'm going to talk about VLANs later. So the private way of working. So that is that. Okay, so that is it now. So this is just example of what we're trying to. So this is a managed switches. So a managed switch is one that you can manage and configure by yourself, unlike the unmanaged that you just plug any switches and start working, right? Okay, so good. So we have another interesting topic. We're going very fast. So this is another important. We have power over Ethernet. So power over Ethernet, just power over Ethernet, just networking, a network switch, right? That has its own power. It has its own power injector. As you just plug it, you don't need to connect power to them. It has power. It has cable. Then it start working. That is we call a power over Internet. Let's take a look. See, power over Internet standard in networking. A power over Internet injector is a device that has power to standard Ethernet cable, allowing you to connect and power. So it's a device that has power, like a switch. Now you get a switch, right? See, the switch has its own power. It has power to do of the switch to the Ethernet cable. See, injector is a device that has power to the standard Internet cable. So what means is that the switch itself already have give power, provide power to your Internet cable. So that is just that. So we're going to move to the next video now. Okay, so we're going to stop here this video, and we'll continue from here in our next video. Thank you very much for listening. So if you have any question, you can place a question on the comment section. I'm going to give you answer, and subscribe so that you can get our videos. Thank you very much. I'll see you in the next video.